Um, so let us start a video with a real-time problem in current generation, which is from the central government. Uh, so title of this problem is design of RF up or down converter for signals using GNU radios and SDRs. So we gave our team name as a Smart Hub and from Andhra Laila Institute of Engineering and Technology, which is the theme of Miscellaneous, which is in central government. So let us describe our idea. So that we gave the challenge is design of RF up or down converters for signals using GNU radio and HDRs can be challenging due to the need to convert signals to the desired frequency range, maintain signal quality and ensure compatibility with various HDR hardware. So a challenge is simple, which is in real time generation. So we are going to design an RF up or down converters for signals using GNU and SDRs, which will change need convert signals to the desired frequency, which will by using GNU radios and SDRs, which will convert them as a real desired frequency range and maintain the signal quality and ensure compatibility with various HDR hardware. So to solve this, we have a smart idea is effectiveness of RF up or down converter design using GNU radio and SDRs depends on how well these design factors are addressed. That means how the GNU radio and SDRs depends on real-time factors are addressed. A well thought out, carefully executed design will lead to a successful RF signal conversion system, ensuring that signals are processed accurately and efficiently within the desired frequency range. It means ensuring that which is given which we are using a GNU radios and SDR. Total project works on using GNU radios and SDRs. By these we can ensure that signal how the signals are processed accurately and efficiently within the given desired frequency range. So here we use the technology like the main area GNU radio and SGRs can be challenging due to need to convert signals to the desired frequency range, which we use the desired frequency range and maintain signal quality, ensure compatibility with SDR hardware. So here you can see a flow chart which indicates throttle old sample rate, which is 10 m, and this is divided as skip head uh, number items 5.00531 m, which is the output of the skip head is given as input to another skip head which is of same value. That output is given to input of multiple conjugation and virtual sync. First skip head output is given to virtual sync, which is with stream ID signal reference, and second output is given as input one, which to the multiple conjugation. Similarly, variable delay, which is which the output is given as input to skip head with the same number items, and output of that is given to again multiple conjugation with input name one. Again, another input is throttle old sample rate with 10 m. Output of that is given to skip head, and output is connected to virtual signal. So by this flow chart, we can observe that the sample rate of the which we give as input, the sample rate is connected as input to is given as input to another skip head, which is skip head are further divided into four skip heads. one skip head output is given as input to another skip head, and two outputs are given as input to one multiple conjugation, which will have two inputs, single output but two inputs. Similarly to the last one is also is given as output is given to the input. So moving on to the next step, describing describe your uses cases here. So we can describe here customer. So how this real time application will approach on current on like cases like customer support, e-commerce, healthcare, like how it efforts on customer support, e-commerce, healthcare, education. And on another side, we described about the dependencies or dependencies like frequency range and bandwidth, component selection, signal conditioning, compatibility with SDR hardware, calibration, filtering and spurious reduction, modularity, size and power efficiency, simulation and testing. So here we go with the customer support. Customer support for the design of RF up or down converters for signals using GNU radios and SDR can be a valuable resource to address questions, challenges, provide guidance throughout the design process. Here, how customer support can assist with here. By this, we can see that here that there is a customer support. It means to the public use, how it affects on how the customer supports to this idea, like for signals using GNU radios and SDRs can be a valuable resource to address. So this can be a valuable resource. Resource means which we can use to address questions, challenges, and provide guidance throughout the design. That means how these GNU radios and SDRs are valuable resources to address questions, challenges, and provide guidance throughout the design process. So, coming to e commerce, creating an e commerce platform for the design of RF up or down converters for signals using GNU radio and SDRs can be a beneficial endeavor for both customers and suppliers in RF and SDR time. So, you can understand that this by using this, how can it beneficial for both customers and suppliers in the RF and SDR technology domain. It means who are in the state domain, technological domain. Either it should be from for support both. It should be beneficial for both customers and suppliers. So by this e-commerce, by this problem, we can benefit both the customers and suppliers. By healthcare, we can see healthcare. In the healthcare sector, design of RF radio frequency up or down converters for signals using GNU radio and SDRs can have several valuable applications, primarily in the context of medical imaging, patient monitoring, healthcare communication system. That means how it affects on healthcare issue. That means how it will be usable in healthcare. So it can the medical image. So we can see medical imaging, patient monitoring, and healthcare communication system. Here are some ways RF converters using GNU radio and SDRs can be applied in healthcare. But coming to education, how it will be effect on education. So educational programs focused on the design of RF up or down converters for signals using GNU radio and SDRs can provide valuable knowledge and skills for individual pursuing careers in RF. It means some are interested in radio frequency engineering, which are interested in frequencies, can helpful. This problem can be help this idea can help them in educating the students, like skills for individual pursuing careers in RF engineering, telecommunication, and related fields. So by coming to dependencies or dependencies, here we pinned some dependencies like Frequency range and bandwidth, which is the first one, determine the specific frequency range and bandwidth requirements of our application. So here we should, for frequency range and bandwidth, we should choose the appropriate mixers, oscillators and filters that match this requirement. To implement this idea, we need a perfect mixers, oscillators and filters. So component selection is like should collect high quality RF components such as mixers, oscillators, filters to ensure low phase noise and minimal signal degradation. So the third dependency is the signal conditioning. Implement signal conditioning techniques within. So we should implement the signal condition techniques within the GNU radio to enhance signal quality, correct amplitude and phase imbalance. So coming to fourth one, compatibility with SDR hardware. Ensuring that up or down converter design is compatible with SDR hardware. Plan to use calibration. Develop calibration routines within GNU radio to compensate for any phase and gain imbalance between in phase and out phase. Filtering and spurious reduction comes utilizing the proper filtering techniques to reduce unwanted spurious and intermodulation products that can degrade signal, which is like similar to noise. So we need to use the proper filter. By using the proper filter techniques, we can reduce these problems. Unwanted spurious and intermodulation products, which is similar to noise. Modularity is a design adaptable, to be modular and adaptable so that they can be easily configured for different frequency bands and SDR hardware. So coming to size and power efficiency, which is used in every application where we see every size and power efficiency. So here optimize the design for size, weight and power efficiency, especially if our application has swap constraints. That means we should optimize our design, weight and power efficiency, especially if the application has pass constraint. That means we should optimize our design perfectly with the size, weight and power efficiency, where we will check perfectly. That means we should, especially here we mentioned, especially if your application has swap constraint. That means if the our token application it has swap constraints, we should check this perfectly before we implement the idea. So simulation and testing. Simulate the RF up or down converter design using GNU radio to verify its performance and conduct real world testing to ensure function. So before implementing, we simulate our product. We simulate our procedure by testing, and we check the simulation process too. So this is the idea from Andhra Laila Institute of Engineering and Technology, which is just from the real-time application, which is the problem of we chosen this problem from central government to implement this design of RF up or down converter for signal using GNU. By means, we want to design an RF up or down converter using GNU radios and SDRs. So here is the idea. Thank you.